Okay. Yeah, so now in this new age, the access to the knowledge is lower and lower, right? With ChatGPT and all this AI technology, to gain the knowledge is no longer a thing. And this is only the starting point. And think about in another 50 years or so, knowledge is really not a thing. When everyone has a knowledge, has access to this knowledge, then the question is really not the knowledge itself, but how you can use those knowledge in a more creative way. And in other words, how you think better. That's why we think in X-Nova, we think the thinking is really the most important skills that we need to know in the coming years. However, unfortunately, in our current education system, we don't actually focus on thinking. The current education system is still to deliver knowledge. I'm a professor in a university. The way how we teach students is still the same as how we did 100 years ago. We stand in front of students, we give lectures, and the students sit there, take notes and try to memorize. That's still how the current education goes. There's almost no systematic education on the thinking. Right? So here in X-Nova, we're trying to bridge this gap. We're trying to deliver not only the philosophy, but also the tools to help people for more effective thinking. We have been doing this through workshop and through some Saturday practice, but now we want to do it in a more systematic way. Right? So we'll start this 50 courses. This is the very beginning of 2025. I think that's a good way to start this year. And we'll do once a week, and in a year, it's going to be 50 lessons. All right. Yeah, that's the plan. And today, this will be the first course. I hope everyone can see this.
Yep, we can see it.
Okay, cool. So in the first course, or actually in the first few courses, we'll talk about the engine behind the thinking. I'm a physicist, so I like to ask always, what's the origin of the thing? What's the origin of thinking? The thinking doesn't come from nowhere. It doesn't just drop from the universe. It comes from a valuable organ of our body, that's a brain. And believe it or not, brain is actually one of the most mysterious objects in the universe from scientific point of view. Again, physics, in field of physics, there are a lot of mysteries. The Big Bang, the black hole, or in my field, unconventional superconductivity. All those are mysteries. But brain is just as mystery as those topics, if not more. Right? From our daily experience, their brain is within your reach. You can touch it, you can feel, you can use it, or you can even, beat it and say Dumbo to it. But from scientific point of view, we don't actually know much about the brain. The whole reason is because the brain sits inside the skull. And skull is like a shield. And so most of our technology cannot probe inside the skull. We have all kinds of fancy technologies. For example, for universe, right? We have telescope. We can reach to galaxies that are far, far away from Milky Way. Or we have microscope to look at things that are very, very small, look at the atoms. But we do not have direct probe to look at the brain directly until very recently. There are some ways to know something of the brain, but a lot of aspects we still do not know. So this is a quote from a neuroscientist. That's like 100 years ago. He says, brain is mystery. It has been and still will be. How does the brain produce thoughts? That's a central question, and we still do not have answer to it. That's 100 years ago, and I think that's still valid even now. We do not know much about how we actually think. So that's really what I think it's a starting point of talking about the thinking. Without knowing how brain works, it's hard to talk about how you can make it more effective to think. However, our point is not to just discuss science. Right? Here in this course, we'll not just deliver the textbook knowledge to tell you, how the brain is made up, those things. We'll talk about the science, it's based on the science, but we want to take advantage, make use out of this. So the perspective is different. So we know a little bit about the brain. I think that's enough to help us to make more effective thinking. So the starting point is not just a science. In this first course, we'll talk about this thing. We'll talk about the two types of thinking that are powered by two types of network. And specifically, there is a so-called task positive network, and there's a default mode network. These two networks together that make us to think, and they are very different. And that leads to two types of thinking. We'll talk about this, and hopefully at the end of the course, we'll be able to answer questions like this. Why can't we focus on our work? A lot of students struggle on this. I want to focus on my homework, but I keep thinking something else. Why can I stop wandering thoughts? That's to some extent, that's why Neo is doing the meditation. Everyone has the experience. We have wandering thoughts, right? From religion's point of view, people have been practicing for 1,000 years on how to tame the wandering thoughts. But it's not until very recently, from scientific point of view, we understand why we have those. Another question, why do I feel overwhelmed by multitask? And another thing, why does inspiration seem to vanish when I try hard? Sometimes I really need an idea. I try really hard, but it just doesn't come. Why? So hopefully at the end of the course, we'll be able to answer some of those questions. Okay, so let's start it. To start, we want to start from the very basic of the brain. Brain is like a computer. The basic unit for a computer is a so-called transistor. This thing is a transistor, and on this picture it looks big, but really now people can make transistor really, really tiny, like a nanometer size. And in a smartphone, like what we have nowadays, there are like 10 billion transistors. Those are really the building block of your smartphone. Without those 10 billion transistors, you won't be able to, use Zoom and listen to these courses right now. Our brain is like another computer. It has similar principles. It's made of the basic units. Those are called neurons. Okay, the size of neuron is slightly bigger than the transistor. However, in our brain, we have a lot of neurons as well. 86 billions of neurons. Each neuron, the size can be different. Some are like a few micron. Some can be as long as meters, one neuron in your brain. And all those neurons are like transistors. They can receive signal and send out signal. Okay, so what does that mean? That means each neuron is connected to other neurons, right? Otherwise, it can't receive or send a signal. Neurons are connected by so-called synapses. And then they form a web, right? If one is connected to the other, all are connected, then form a web. And in neuroscience, we call it network. Okay, so here's the question. How does a network really look like? If you just think about this question, the simplest answer you can come up with is a simple, uniform network. Right? There are 86 billion neurons in your brain, and all of this uniformly connected into one network, one web. Actually, in nature, some creatures do have this type of network. This picture is from a jellyfish. It's not until recently people really understand how the network of jellyfish look like. Jellyfish does not have a brain like ours. Basically, their neurons are distributed all over the body. It's like more or less uniform. It's not really uniform. You can see that it's centered somewhere, but is more or less distributed all over the body. So the key message is there is basically one network, and this one network does everything, right? When jellyfish needs to eat, or when jellyfish needs to run, it's the same network that gives this message. So the same information will get distributed all over the entire body. However, this type of network only exists for the low-level creatures. And for more complicated creature like us, nature has a different answer. That is, we have specialized networks. Okay. The reason for this, you can imagine, right? The simple network like this is very hard to deal with complicated tasks. In our case, the network is divided into different parts. In our brain, there are networks just for visual. There are networks just for motor. Right? The part that controls what you see and the part that controls how your hands move is different network. It has advantages because in this case, the information for visual will only distribute it in that part. So it can be, concentrated in a small region, and the speed will be faster, and the brain can develop specialized features for this network. So we have specialized networks. That's the answer for more advanced creatures. And this is exactly the reason how we can actually think. If we remain this simple uniform network and one network deal with all the things, we won't be able to think. The networks I listed here, most of this are for the basic survival needs. But we do have two special networks that made us to think. The first one is this task positive network. Okay. The reason why it's called task positive network is because people use so-called fMRI. It's a functional MRI. So use this equipment, people can detect which part of the brain is actually active when you do things. So people are able to correlate the region that is related to the task management, or task execution. Therefore, those regions are called task positive because it's positively related. So basically, this part of a network is responsible when you deal with tasks. For example, I'm talking here. There must be some sequence, some signal to make me think what I want to talk and make me concentrate in my talking. That's the task positive network. This network is only like 20-ish% of the entire brain. However, without this part, we won't be able to think. If you don't have this part, you stand in front of a door, you don't know, should you open the door or close the door? If you want to open the door, you don't know which key should I use. Do I need to use a key or do I need an umbrella to open the door? You won't be able to figure out that. So one of the most important things for task positive network, let's call it TPN, is actually so-called logical thinking. In order to perform a task, you have to be able to do the logical thinking. Otherwise, again, you sit in front of the door, you won't be able to figure out you need a key to open it, or you need an umbrella. You need logic. And the logical thinking, of course, is the most important thing for civilization. I'll just illustrate how powerful logical thinking is. Let me give one example, my favorite example in physics. So we all know atom. In physics, we say never trust atom because atom make up everything. Someone said, if we destroy all the knowledge human being generated, and we leave just one piece of knowledge to the future generation, someone think this piece of information should be the one that we pass to the next generation. Everything is made of atom. That's how important this information is. And atom, really, it was discovered only like 200 years ago. However, the name atom, or the first theory, first model of atom, was conceived 2,000 years ago by this guy, Democritus, and is an ancient Greek philosopher. He discovered, or he created the concept of atom purely based on the logical thinking. How? So he observed when a tree is burned, a tree turns into ashes. It's a simple observation. And based on this observation, he starts his logical thinking. He thinks, how could this be? How can a tree turn into ashes? Then he said, okay, there could only be two possibilities. The first possibility, the ashes was hidden inside the tree. When you burn the tree, basically you release ashes. He thinks this is less likely because, even in the ancient Greek, they cut trees, they open it, right? They know what's inside. So he thinks this is not possible. This goes against his daily experience. Then he thinks there's only other possibility. That is, both tree and those ashes are made up of the same smaller unit. So it's like Legos. Both are made of smaller pieces. The tree just breaks down into the smaller pieces and turns into ashes. He named those smaller pieces atom. So this was basically based on the logical thinking. He did not observe this, but based on the logical thinking, he concluded there must be something called atom. And then in around 19th century, people from observation, people really confirmed the atom does exist. And really it's about 20th century, from experiment, people observe the atom. This is the power of the logical thinking. So we want to ask, how does TPN actually make sure a logical thinking? Right? It's powerful, and we use it every day. Right? But how? How could this actually happen? For example, we see this, right? X equal plus 3 equals 5. How does it actually make sure you answer X equal to 2? That's a logical thinking. If you answer bananas are delicious, that's totally irrational, not logical. However, how does the brain actually work to ensure your answer is X equal to 2? It's very complicated. And basically, there are 4 types of mechanism to ensure that you get to the right answer. So first, TPN has to retrieve the right logical rules from the long-term memory. Those long-term memory is stored in this temporal lobe. And TPN needs to go there, retrieve the right logical rules. So in this case, TPN needs to retrieve logical rules regarding, for example, addition or equations or moving and combining terms. If TPN retrieve logical rules about which fruits can be eaten, right, then you'll get to the wrong answer. So the first mechanism, it needs to retrieve the right logical rules. However, it does make mistakes sometimes. So that alone is not enough. You need something to monitor. And TPN has a mechanism to monitor this. It has a real-time error monitoring system to make sure you do not make mistakes. And this part is taken care by this called ACC. This ACC is part of the TPN. This part is like a monitor. However, this part does not do the calculation. It doesn't do the logical thinking. It just monitors. Then you would ask, well, if it doesn't do it, how does this part know if you make mistake? The answer is it relies on the past experience. Okay, it doesn't calculate how much is X. However, if your answer is bananas are delicious, ACC will send a red flag, because ACC will say, okay, well, typically in a similar situation, your answer are always a number. That's my past experience. Now this time, your answer is a fruit. There must be something wrong. Okay, then red flag. For example, you go somewhere and you get lost. ACC will send a red flag because it's somewhere you doesn't recognize. ACC will say, hey, this is wrong. This goes against our old experience. This place, I have never been there. That's how you know you actually get lost. That's the second mechanism. The second mechanism basically is a negative feedback. Okay, so you can imagine there must be a positive feedback. And the positive feedback is a reverting mechanism. We all heard about this word, the dopamine. The dopamine is a neuron transmitter that makes you feel happy. Makes me feel satisfied. Feel, the source of the joy. And it comes from the dopamine. So when you start, when you do it right, it will send dopamine to encourage you to keep going. The dopamine will be released even at the very beginning when you see this problem. When you see x equals to 3 equals x plus 3 equals to 5, to solve this problem, at the moment you see this problem, the dopamine is already released to tell you that, hey, work on this. Once you work on this, once you solve the problem, we'll get more dopamine. This is like before you start the work, you already get a paycheck. And each step during the process, when you solve the problem, will release dopamine to encourage you to keep going. And until towards the end, at the very end, we solve this correctly, and there will be a surge of dopamine, making you really feel happy and satisfied. And once you do this over and over, the neuron connections for the right answer will also be threatened. And in that case, next time, it takes less time to directly get to the right answer instead of bananas are delicious. Those are the basic three mechanisms to ensure a logical thinking. However, even that, those are not enough. There's one more mechanism to make sure a logical thinking. That is, brain needs to make sure you work on the right problem. So it has to filter out the irrelevant information. For example, you're working on this problem, and then you hear someone playing the video game, or you smell someone is eating a delicious food. Your attention might get shifted to the video game or to those delicious food, and then you answer bananas are delicious. The brain, the TPN, wants to stop those. So it has to filter out the irrelevant information. So this is how complicated, how much TPN has to do to make sure a logical thinking. And we should really, appreciate this. So during our daily life, we think, logical thinking is granted. We can do some calculation. We think, that's just natural. But actually, it's not. This is years of evolution. At this point, it has its power to do this. Have all this mechanism to ensure. However, there is a consequence of this. Because of all this complicated mechanism, TPN is very, very energy consuming. You average, okay, so brain actually, in terms of weight, in terms of mass, it's only like 2% of the total body. But it consumes more than 20% of the total energy. When your brain is at rest, okay? So this takes average of all the energy consuming of the brain. when the TPN is active, the energy consuming doubles. Okay, so it doesn't mean it goes to 40% of for the total brain. It's just that the part of the TPN, the energy consumption will double. And because TPN is only 20% of the total brain, and the energy consumption of the brain goes to like 25%. But that's a huge energy consumption. Okay. So if it keeps using TPN, it consumes a lot of energy. Fortunately, TPN is not always active. We don't do everything that use TPN. Most of the time, actually, we do not need TPN. For example, we sleep 8 hours a day. You don't need to do the calculation. And even during the day, we don't spend every minutes to do calculations, to do task-related problems. And so a lot of the time, TPN is not active. Then you would think, okay, how do we, since TPN is not always active, how do we actually save energy? And since we're talking about logical thinking, a logical way is just like your laptop. A laptop is not working, is not active, we send it to a sleeping mode if you don't want to shut it off. In a sleeping mode, everything else is basically shut off, but the short-term memory is there. So long-term memory, of course, you won't get lost until you damage your hard drive, but short-term memory, for example, which document is open and which sentence you're editing, the short-term memory is saved in a sleeping mode. Otherwise, it's totally not active. So we would think, all right, in order to save energy, we can just send your brain into a sleeping mode. Of course, all the other networks that ensure your basic survival cannot go into a sleeping mode. But the part that for thinking, if it's not active, we should send it to sleeping mode. The reality is, brain never stops thinking. We mentioned at the very beginning, we have all those wandering thoughts. Everyone has this experience. Even when we do not solve math problem, do not think how to make a PowerPoint, do not think about how to write an email. Even when we do not do those really a task, we still have wandering thoughts. The brain never stops. So basically, we do not go into a sleeping mode. This is because we have a second network. It's called default mode network. And default mode network, just from the name, you can kind of guess what it is for. It's a default mode. It's like a sleeping mode. But this sleeping mode is a lot more active than your computer sleeping mode. It's not just a short-term memory. It actually does things. There are a lot of things that default mode network, or this DMN, can do. Daydreaming. I bet everyone had experience for daydreaming. Imagine the future. When we imagine the future, you don't need a logical thinking. You don't need to calculate. You can imagine, okay, well, next year I'm going to a vacation. Or you can imagine, okay, next year I get a promotion. There's no logic. There might be some logical, but at least you don't have to do the calculations. Real dreams, not daydreams, the real dreams. When you sleep, your brain is working. And for example, all of a sudden you retrieve a past memory. All of a sudden, when you brush, all of a sudden you think, oh, when I was 10 years old, I went to some hotel and I used the same toothpaste. And most importantly, those aha moment. So default mode network actually does a lot of things. All these things are from this default mode network, DMN. To understand DMN, a very important thing is, again, why do we even need a DMN? That is to save energy. Because TPN consumes too much energy, we want to send sleeping mode, but we do have a different sleeping mode, that is DMN. So this DMN must save energy. The way how it save energy is in a spontaneous mode. Right? So it basically removes all those mechanisms that make sure a logical thinking. DMN doesn't have any of those. It's more spontaneous mode. That's how it saves energy. In the nature, almost all the spontaneous mode save energy. Think about getting food. Think about a cow eating on the grass, right? The cow eating grass, there's almost no clear object. It just keep eating, right? There's no clear place where it needs to go. As long as there's grass, it just eat. It's a spontaneous mode. And comparing to a lion, when lion chase a prey, there's a clear task, clear object it needs to chase. So it needs to gain all the energy and work really hard to catch the prey. In Africa, in average, the success rate is only 40%. 40% of the time, lion can actually chase the prey. And after this, it gets really exhausted. And if it failed, then because it consumes so much energy, sometimes it can actually get killed by the prey if the prey is a bigger creature like an elephant. That's how much energy it will consume. Or, for example, organizing a party. If it's a spontaneous party, a few friends just come together and say, hey, let's just hang out. You almost do not need any energy. But if you need to organize, for example, a wedding, it's a well-organized event. You have to spend a lot of time, a lot of money, and do this really in advance and consumes energy. So spontaneous mode always saves energy. Because of this, DMN, because it's spontaneous, there's no structure. It's like cow eating grass. There's no logical because it doesn't have all those mechanisms that consume energy that to make sure a logical thing. It doesn't have. But it is indeed this unstructured, not ordered type of thinking that does amazing things. Okay. So that one, that the ability to randomly combine, apparently unrelated stuff, that is actually a function of DMN, right? Because it doesn't have the mechanism for logical thinking, then it actually does a good thing. It can randomly combine things and turn it into something, we never think, and that's called imagination. And sometimes it's called creativity. So now we know for thinking, for our brain, there are two parts of the network that gives you two types of thinking, the TPN and the DMN. And these two, they work together. And DMN, the feature is spontaneous, unstructured ideas. And because it's spontaneous, they connect different things that facilitate creativity. And not only that, because it doesn't do the logical thinking. And typically, it does not need outward information to work on the DMN. DMN, a lot of times, it work on the inner information. That's called self-reflection. And DMN process the past experience, connect the old memories, and come up with new ideas that can guide future directions, future decisions. And DMN is also actually related with feelings, with emotions, and encourages empathy and understanding others. That's function of DMN. And the TPN on the other side is what we are more familiar with, logical thinking, logical reasoning, problem solving, and help us to focus on certain things. And in order for that to work, again, it needs to retrieve precise and detailed information. Otherwise, you can't do the logical thinking. Right? And in order to do that, the thinking is always structured step by step, and it has to monitor. There's a mechanism to monitor the process to make sure it's correct. And if it's not, it adjusts the action to meet the requirements. Now, the TPN and DMN are not separate. They work together. For example, when you come up with a new idea, right, the DMN starts. It connects the unrelated topics, generates something new. That's called new idea. Once you have that new idea, the idea goes from DMN goes to TPN. The TPN will use its logical thinking, with its structured thinking, to come up with a detailed plan how to execute that idea. Once the idea is executed, there might be problems you encounter. And when the problem is encountered, it needs new idea to solve the problem. Then it sends to DMN again. So TPN and DMN, they work together. Okay, so these are a few ways they can collaborate to give us a better thinking. For example, idea generation and execution. That's what we just mentioned. The DMN will generate creative ideas, and TPN will evaluate and execute the ideas logically. So we do need DMN and the TPN together. If you only have DMN, you only have ideas and you can't execute. That's actually what some people are missing. There are a lot of good ideas, but we are missing a concrete plan to make them into action. But some other people are missing DMN. We have power to execute, but we're waiting, desperately waiting for new ideas. So some are good at DMN, some are good at TPN. So we need to combine. Another thing, we need to DMN and TPN work together to balance the rest and focus. For TPN to work, for a task to get executed, your attention needs to be focused. And again, there are mechanisms for TPN to make you focused. It filters the other information. So your attention is constantly focused on one thing. It consumes a lot of energy, a lot of energy. In order to get rest, we need to shift from TPN to DMN. So we can constantly do the TPN. We constantly focus on one thing. It needs a lot of energy to filter other information. We can't do that. So we need a DMN to give a rest. They work together to integrate the past and the present. Okay, DMN is good at connecting things. The stored information, DMN can connect all those informations, and then TPN apply this for the future, to solve the problem or current problem, and this will form a feedback loop. The DMN is like, I generate ideas. Are the ideas right, wrong? TPN validates idea, and these two make together to make sure the efficiency, the energy efficiency. The total reason for the DMN to even exist is because we need to consume energy. So whenever it's needed, the TPN will shift to DMN. So in some sense, these two, they work together, but also they compete. They're like yin and yang. They do work together, but they compete. Because when TPN works, it needs to suppress DMN. DMN wants those wandering thoughts. If you are working on x equal to 3, x plus 3 equals to 5, and then you're thinking, what should I eat? Right? That's what DMN gives you. Then you can't constantly work on the problem. So TPN has to suppress DMN in order for the task to be performed. But all this on the same time, DMN also wants to press TPN, because DMN is saying, oh, you're consuming too much energy. Like, take rest. DMN constantly wants to drag to the DMN part to save energy. So they're competing also. They collaborate, they also compete. It's like yin and yang. So up to this point, we hope we learned a lot about these two types of thing, and I hope we can we can answer some of these questions. For example, why can I focus on my work? It's
Are you asking
because,
us?
yeah,
Oh,
yeah,
yes?
yes. Anyone here?
Sure, I can go ahead and share some hypotheses, some
Yeah.
ideas. Um, well, one possibility is the TPN network doesn't have the energy required to stay active. Um, so you might desire to focus on your work, but the metabolic oomph isn't there, so the DMN activates to rest you. Um, um, maybe you haven't engaged a TPN for some other reason. Maybe you have an inability to suppress the wandering thoughts, the spontaneous mode for one reason or another. Um,
Why does inspiration seems to vanish when I try really hard? I think many people have this experience. I have this experience when we really want to come up with a good idea. The harder you work on and the longer it takes to come up with the idea. And the idea always comes, just like when you don't work on it, it comes up. So why does that happen?
because the default mode network needs to activate, and that means you have to stop focusing and enter a mode where you're less outward and more wide background thinking. Like you gave the example of the default mode network, like a cow eating grass. Yeah, like sometimes you work on a problem really hard, and then you switch to washing the dishes, and you forget about the problem. But in the background, the default mode network is chugging along. But if you don't switch to washing the dishes, it never gets this chance to activate because you're in the other polarity, in the TPN always.
Yeah, I like that answer. That's basically it, right? We need to switch to DMN in order to come up with new ideas. If you work really hard, you're constantly activating the TPN. And if you think about the current education, when you work on all these problems, you are actually constantly activating your TPN. So, in my opinion, the current education is totally about using your TPN. Very occasionally, you use your DMN. Right? That's when you sit in the classroom, you are daydreaming while professor is giving lectures. But otherwise, to understand the lecture, right, to take notes, to do the homework, you really need a TPN. But that's exactly when you suppress DMN, you suppress the opportunity to come up with new ideas. And so we're, in some sense, suppressing the creativity. Okay. Um, so that's it about the philosophy part. Now we want to introduce a tool. So each course will be one philosophy, one tool, and one practice. So the tool, since this is the very first course, will introduce this powerful tool that actually help you to activate the DMN. Right? Now we have tons of tools to activate your TPN. Everything that you do in the classroom is to activate your TPN. All those are tools. But do we have a tool to actually activate the DMN? This is our tool called iTalk. So that's where you find it. It's on our website, italk.so. And once you open the website, it asks you to register. So you do need to log in. And once you log in, this is part you will see. And here you can put a title, then click on iTalk. And once you do that, you will see this form. Okay. And people will say, hey, it's an Excel file. And I'm into my TPN mode. No. Here is how this tool actually help you to activate DMN. The reason why it's called iTalk, we want you to talk instead of typing. Okay. And when you talk, your DMN start to work. This is why. We want you to talk randomly. You have a vague idea, what do you want to talk about? For example, your topic will be my homework. Okay. But you don't really talk about this thing logically. At some point, at the end of this form, we'll go into TPN. But to start, we'll use DMN. We want you to talk and randomly talk. Whatever comes to your mind, and just talk about this. The more you talk, you actually activate that mode. When you random talk, that's DMN. There's no logical thinking. Right? You have to really think hard in order to get TPN. We don't want you to really think hard. Just follow your brain. It's like water is flowing. It doesn't matter where it goes. Let it go. A cow is eating the grass. Let it go. Wherever it wants to go, let it go. Okay? By doing this, you actually activate the DMN. Just keep talking and let your thoughts jump from one to the other. Let the wandering thoughts come out. Even if your topic is my homework, then you think about, oh, I'm hungry. Oh, this thing is delicious. That's something TPN wants to suppress, but don't suppress that at this moment. Let it be there. By letting it be there, you encourage the DMN to work. You're telling your DMN, no, you're valuable. Give me more thoughts. Give me more thoughts. Every time you say, you record, you are encouraging your DMN to work. Otherwise, in our normal mode, we have a thought, oh, I'm hungry. You try to ignore. By ignoring it, you suppress DMN. So we're doing opposite thing. We want to encourage DMN to work. But this tool is not only about DMN. So we want you to freely talk in each of the column. There are 9 columns. When you finish one, you can switch to the other one. When it's kind of long, you keep talking. You keep talking, go to another one. When you finish all the 9 columns, or sometimes you stop here, that's also fine. And then this is a moment we want to switch to TPN. We're done enough of DMN. We want to do the collaboration. So now you start to do the column summary. You summarize what you just said. Now this is time we need to be a little bit rational. You have to look at what you said and extract the essence. Okay, but again, this is not a mathematical problem. So you're using TPN, but not heavily. So use your rational thinking to summarize and rational thinking to give a summarize on the whole form. Okay, so here is basically DDMN. Here we have TPN for the summary. And then when you finish all this, you have here we encourage you to have just one sentence summary, have the essence of the entire form you just talked about. Now we use DMN again. Based on that one sentence you just wrote, expand, use your imagination, use your connections, connect all these ideas and write into a 9-line wisdom or sometimes a poem. Right? This is where your creativity comes in. You expand. So this simple form, even though it looks simple, it combines DMN and TPN. But more, we emphasize on DMN because we have already too much training on TPN. Right? We don't need more training. We mainly focus on DMN, but it does combine the functional TPN. Okay, so this is a form, this is a tool that you can use in your daily life as a practice so that you get familiar with this. Okay, practice 1. use this I talk tool to talk about one thing that happened in your life today. And the key points are, talk about this thoroughly. Think about any aspects. Don't confine to yourself, oh, I can only talk about that thing itself. You can talk about anything related with this thing. It can be, for example, I had a fight with my mom during the lunch, right? You can talk about why that happened. You can talk about the consequence. You can talk about anything that's related with this. Anything that comes to your mind, we talk about this. Okay. An important thing, you want to draw reflections, make connections. That's an important function of DMN. That is, draw reflections, make connections. And thus, you do want to allow your thoughts to jump around. If we talk about the thing, all of a sudden you remember you have an email to reply, that's also fine. Give yourself time. If you feel like, oh, I'm done, I have no more to talk about, just give yourself 10 more seconds. I'm sure something else will come in. Okay. And towards the end, we can share.